Today we are taking notes on vertical motion. You should have out your graphing calculator and the note sheet that you got in class. You should have a sheet that looks similar to this that says vertical motion notes that you either taped, stapled, or glued into your notebook. Okay, we're going to start by writing down the vertical motion equation. The equation is h of t is equal to negative 16t squared, add vt, add ho. T in this case is time. Probably could have guessed that. H of t is the height of the object after t seconds. So the height after 2 seconds, 5 seconds. V is the initial velocity. And then h is the initial height. So the example, an object is fired straight up from the top of a 150-foot tower at a velocity of 75 feet per second. Part A, write the vertical motion model to reflect the information above. So your model is going to be h of t is equal to negative 16t squared. Because it's h of t, you should always have a t in your equation. Add. Now we are told an initial velocity of 75 feet per second. So we're going to add 75t, and then it says a height of 150. That's going to be our initial height. So here's our vertical motion model. This is a quadratic, so it's going to be a parabola. Because of the negative 16t squared, the parabola will open down. This should make sense. If we have a tower, and we shoot an object off the tower, that object is going to rise, and then it's going to fall again. That's why we end up with the quadratic or the parabola shape. B, use the model to predict the height of the object after 3 seconds. So we are looking for h of 3. When time is 3 seconds, what's the height? We're going to get that by substituting 3 in for t. Now we need to go to the graphing calculator. I've already done this one for you. So when I substituted in 3, I got 231. So your answer then is 231 feet. After 3 seconds, okay, now moving on. Part C, at what time or times will the object be 235 feet off the ground? So that 235 feet is the height. So we're going to substitute that in for h. The height is 235, and I'm looking now for t. I'm going to start by subtracting that 235 so that my equation is set equal to 0. Now my equation is set equal to 0, which is what I wanted. I'm going to use my graphing calculator now to calculate the zeros. So hopefully remember how to do that. Let's go back to the graphing calculator. Go to y equals, you want to put in your equation, negative 16. Instead of t, we're going to use an x. So x squared, add 75x, and then subtract 85. I'm going to go to zoom 6. And I can see here that I will have 2 zeros because the parabola crosses the x-axis twice. So now we're going to go to second calc. We want to calculate the 0. Okay, left bound. Okay, I can see the point there. That's the left bound. Hit enter. Here's my right bound. Hit enter. Yes, we want the calculator to guess. So our first 0 is 1.92, 0. So let's go back, write that one down. Now we have to go back and calculate the second 0. So again, we want to calc the 0. This time the left bound is above, so hit enter. Right bound is below, hit enter. Yes, we want the calculator to guess. So our second one is 2.77, comma 0. The question specifically asks, at what times will the object be 235 feet off the ground? Remember that these are times. So we would say at 1.92 and 2.77 seconds. Okay, now it says, why are there two positive answers? If we remember what we talked about in part A, our object is going to rise and then it's going to fall again. There are two positive answers because our object is at 235 feet twice. Once when it is rising and once when it is falling. So let's write that. The object reaches 235 feet as it rises and again as it falls. Okay, so that was part C. D, what is the maximum height the object reaches? This time we are looking at that original equation that we wrote in part A. This parabola opens down, which is why it has a maximum. The maximum is going to be the vertex. So you're either going to calculate the vertex by hand, or you're going to calculate the maximum on the calculator. So I'm going to choose to do it that way. Let's go back to the calculator. Here's where you need to be careful. This is not our original equation. This is the equation we wrote in part C. So the first thing that you need to do is go to y equals and change this equation to the one from A. All that's going to change is that height. So that negative 85 is going to become positive 150. Now I'm going to do zoom 0 this time so that I can see the maximum. Second, calc. I want to calculate the maximum. Okay, so we can see our point there. This is clearly to the left of the maximum, so I'm going to hit enter. Now right bound. We're going to have to go right for a little bit. Sorry, my calculator is a little bit slower than yours, I think. Okay, this is clearly to the right. Hit enter. Yes, we want the calculator to guess. Hit enter one more time. So 2.34, comma 237.89. Let's go back, write that down. So we got 2.344, comma 237.89. So we would say our maximum height is 237.89 feet, and then that's at 2.344 seconds. So it takes the object's 2.344 seconds to reach that maximum height. Last one is E. How long does it take for the object to fall back to the ground? So back to the ground, that means the height is 0. So 0 is equal to, and then our equation from part A. So again, we want to calculate the zeros. Let's go back to our graphing calculator. I would just check y equals to make sure, yes, this is the equation that we want. So we're going to do zoom 6. Okay, so we can see there's two zeros here. One that's negative, one that's positive. We don't want the negative because that's going to give us a negative time that doesn't really make sense. So we're looking for that 0 off to the right. We want to do second calc. We want to calculate the 0. Probably going to have to go over here for a while. So you can see that your y is decreasing now, which means we should be able to see it soon. I think I passed it. Okay, so there's the left bound, hit enter. Here's the right bound. We can't see the point, that's because y is at negative 23. That's okay, hit enter. Yes, we want the calculator to guess. So we get 6.1996, comma 0. Go back, write that one down. Sorry. Okay, so we get 6.2, comma 0. So how long does it take for the object? It takes 6.2 seconds. Okay, so that was vertical motion for you. Tomorrow you're going to come into class and we're going to do a vertical motion example, and then you guys are going to start your homework.